Hello, in this video we're going to build a logistic regression model in the R programming language. Now the problem that we're going to solve for this model is we are going to try to predict a home equity line of credit default. So the data set here has the variables up here. I have a comma-separated variable data set here, and the very first line has the variable name. So bad is my target, and if you are a bad person, you did not pay me back on a home equity line of credit loan. So a lot of the people at the top of this list are bad, so they have a lot of ones up there, but if you move down I have a lot of zeros. It's about 80% of the people do pay you back, about 20% do not in this data set. So bad is my target and 1 is a bad person. Also, this data set had some missing values. So I have, before creating this data, or before showing you this data set, I've already fixed the data. And this data now has imputed values. So if I know, for example, what your loan amount was, I will have included it. Otherwise, I imputed or fixed the value with the median. So that, it's a real simple way of fixing the values. It just took the midpoint, and that's my and that was my imputed value. And so this is the data set. All they are is just numeric values. And so the variables that I have is loan amount, mortgage that they currently have on their house, the value of their house, years on job. People who stay at a job for a long time tend to be more responsible. The number of derogatories. This is how many times you've, let's say, charged off. You didn't pay your credit card bill, and so they cancel it. That's a derogatory. A delinquency is just a late bill that you eventually paid. Credit line age. The longer your credit line history, the more responsible you are. So this is how many months of credit history you have. Number of inquiries. This is times where you ask for, they do an inquiry for you at the credit bureau. The theory here is that the more times you go to the credit bureau looking to get credit means that you are a risky person, because if you're looking for credit cards, it means you're running out of money. CL number, CL no, that's number of credit lines, and this is the more credit cards you have, the more risky you are. And also debt to income ratio, so you take your total debt and divide it by your total income. The higher this number, the more risky you are. So these are the variables I have. So what I'm going to do is we're going to build an R, we're going to use R and build some logistic models. Since the target here is 1 or 0, this is the type of model that we would build with logistic regression. So now the first thing that we're going to want to do in the R programming language is we are going to need to install. If you go out there, there's lots and lots. Since R is an open source language, there are a lot of open source packages to do various things, like, let's say, neural networks and random forests and gradient boosting and clustering. There's all sorts of things you can do with the R programming language. They're not all, when you download it, they're not all there. You have to go get them. Now I'm going to show you right now how to install a package. Now at this point we're going to assume you know what the package is you're looking for. This is not an R programming class, so what we're going to do is just assume that we happen to know the name of the package, and this is how you do it. You can come up here and you do packages, and we're going to install a package. Well, actually the first thing you do is you set your CRAN mirror. Now this is where you're going to go get your packages from. Now when you click on set CRAN mirror right here, up comes a window of all sorts of places that you can go and download. These are all the same files everywhere, but in my case I live in Ohio, so I'm going to want to, doesn't have the one I want to go to, so I'm going to go click on this guy and hit OK. Now it doesn't really matter which one of these you select, but you should probably get one that is closest to you. And I live in Ohio, so I happen to know this is one in Cleveland, so I'm going to do this. But if you guess wrong and you choose the wrong one, life doesn't end. But for whatever reason, you're asked to choose one closest to you. So I'm going to choose this one. So I have now chosen the Cranmere in Cleveland, Ohio. Now I'm going to come over here and I'm going to install the package that I want. And if you click Install Package, up will come a window with all of the available packages that you can download. Now, normally you need to know what you're looking for, and there's ways you can find that out. It's not the scope of this to show you these, so I'm just going to tell you that the one that has logistic regression that I'm looking for is called MASS. So I'm going to go look for that, and here it is. So I hit Mass. Now I've already installed it, so I don't know what happens when I'm going to try to do it again for you. But I'm going to hit Mass, and I hit OK, and R is going to try to install it. It might be telling me that it's already installed. Apparently it reinstalled it, and that's fine. So now it's in there. So now what we're going to do is I've written some R code already to do this. So let's go over here, and the first thing you need to do is load this library. Now everything we've used up till now has been using default things, but now we're going to load a new library. So we're going to do this guy here, and so he's basically loading mass at this point. So we've got this library loaded into memory. Every now and then you might get a little warning message that says, hey, for example, I'm running an earlier version of R, but this mass is built with a later version. That usually is not a problem, but just letting you know you might get an error message or a warning message. Now the next thing that we're going to do is we'll set the path as we did before. One thing I haven't mentioned earlier is that in Windows, the directory identifier, or the slash, goes in a different direction. So if I were to do this in Windows, it would look like this. So that's what we use backslashes in Windows. But if you do any copying and pasting of your directory names inside of R, be sure that you change it to / instead of backslash. So okay, let me just take these two guys and set these two variables. And now the next thing that we're going to do is set our working directory, and that basically is telling R that if I don't tell you what directory it is, look in this one here. And then we're going to come over here and we are going to read in this file right there. It has a header and we separate it by commas. And then I'm going to print the first 6 records and the last 6 records. And I'm going to put that data right in here to a variable called sData. And there they are. So I've got the first 6 and the last 6. Now the first thing we're going to do is, let me open this guy up here, is I'm going to build a model like I did before with all of the variables. So again, remember, bad is my target, and it is a binary target. It has 1 or 0. So this is a generalized linear model, because a logistic model is a type of generalized linear model. So this is my target, and I want you to predict, or I want R to predict that target with all of these variables. Use this data set. And by the way, I have to tell the GLM that this is a binary target. There's lots of other types of generalized linear models, and so I have to tell R which one I want him to solve. So we're going to do that right here. And there we have it. So I've got here's my coefficients right there, and This has an AIC of 4167.5, and people say, is that good or bad? The short answer is you don't know. It is a relative. Remember that the AIC and the Schwartz-Bayesian criteria and these types of metrics, it is a simple matter of the lower one is the preferred model, and you don't know. There's no such thing as a good AIC or a bad AIC. It's just simply a metric, and you have to compare other models to this metric, and the lower one is better. So this is a meaningless metric outside of a context. The first thing we're going to do is a backwards selection. Now I'm going to name this new model m.backwards. I could have named it anything I wanted, Fred, Joe, Mary, whatever, but I'm going to name it model. This is my personal convention, M for model, and backwards because I'm going to do a backwards selection. So I'm going to give him this guy right here with all the variables, and I'm going to say, hey, do a backwards selection, and I want you to, these are all of the variables that are currently in the model. I'm also going to do a stepwise where we go, take things out and put things back in, but we'll do that in a minute. Let's just first do the backwards selection. And there they are. So if we take a look, he starts off with an AIC of 4167. We don't know if that's good or bad, but we do know that if we remove the credit line number, the AIC drops to 4165. And then after we remove that guy, if we remove the years on job, it drops to 4164. And so at that point, if we do nothing, it stays the same, but if we start removing anything else, it starts to get worse. And so now let's come over here and do a backwards selection. In this case, we're going to remove and add variables. So let's do that. And see, at this point, instead of it being backwards, I have go both directions. So at this point, he says, well, if I remove the credit line number, of course, as before, that's the best guy. Then he removes years on job. R does consider adding things, but none of them are improving things beyond, putting the number of credit line number back in. Going in both directions, it will consider putting things back in that it took out. However, in this case, it doesn't do very well. So the best thing we did is to get rid of the number of credit line, and then the next best thing, we get rid of the years on jobs, and then do nothing. And so that's the answer. So at this point, the going in both directions or the backwards, they both converged to the same answer. Now we're also going to look at a model where we just have the intercept. So we don't even have any variables in the model, just an average value. So let's do that. And we'll call that m.1, meaning it just has just an intercept. So let's do that. And if we want, we can actually summarize this guy. And there you go. So this guy right here is nothing more than an intercept and no variables. Now what we're going to do is a forward selection. So we're going to give him this guy right here, and we are going to do a forward selection, and we are going to consider adding any or all of these variables. So let's do that. Let's see what we get. Okay, so what does he do? He adds the derogatories. Oh, I'm sorry, I don't. He first adds the debt to income ratio, then the delinquencies, then he adds the credit line age, the number of derogatories, the number of inquiries, the mortgage due, the loan amount, the value of the house, and that's it. Seems like the only two he doesn't add is years on job and the number of credit lines. So in other words, it looks like this guy going in the forward direction has now converged to the same answer as before. And let's do a stepwise where we're going to go both put things into the model and take them out. Let's just see how this one fares. I suspect, I don't know, but I suspect it will give me the same answer as the other ones. Okay, let's see what happens. So he adds the debt to income ratio, adds delinquency, adds credit line age, adds derogatory, adds number of inquiries, mortgage due, loan amount, value, and then nothing. So at this point, it's all of these guys converged to the same value. Now, the next thing we're going to do is let's take our data set and copy it into a new data set called X. This is a convention that I follow, which is before I start monkeying around with my data, I like to make a copy of it so I don't screw things up. So if I do head and X, this will give me the first 6 values of X, and tail X. This will give me the last 6. So you can see that I have these guys are, X now has that. So now the next thing I want to do is a predict. So I want to do predict, and we're going to use this model where we used all of the variables. Now, one difference from before when we did a predict, it just was predict and then the data. When you have a logistic regression, you have to type equals response. And this is going to convert it into a probability. Why is it doing this? This is just simply the syntax of the command. So if I want to predict this guy, let's do this. I have to add this guy right here. So let's try that. So head X, and you can see I've got all of these guys that I had before, but now I've got a new column, predictive model.all, and this is the predictive value with all of this data. I predict that there is a 44% chance that this person is going to default on a loan. This guy has a 72% chance. This guy's got a 37. This if I use all of the variables. Now, the rest of these guys are all the same model. Backwards, backward step, forward, and forward step. They're all going to give me the same prediction because remember they all had the same variables. So I don't really need to do all of them. I'll just do one of them. This guy right here. And just for fun, let's do this guy here where I just take the average amount. See what he gives us. And if I use all of the variables, he predicts 44.1% chance that he defaults. If I use it backwards, it's 44.7%. And predictive model.1, this guy right here just uses an average, which the average in this case is 19.9% of the people default, so he just is going to assume that everybody has a 19.9% chance of defaulting. So this is how this is done with R if you want to do a logistic model. Again, this class is not designed to make you an R programmer. The purpose of showing you this is for you to become familiar or comfortable with the language and what is going on. Because if you are a manager or a person working alongside an analytics person, you should at least have a flavor. They will very likely be using this language or maybe SAS as their, or maybe Python as a language that they're going to be doing their analytics in. It should not be like them talking ancient Greek. This is something you should at least be somewhat familiar with. And if they mention something like an R package, you will know where that came from and how they got it. And when you hear the word CRAN, CRAN is, if you remember, the place where we get all of these R routines that can do all sorts of things like, I don't know, random forests or clustering and text analytics and all that stuff. It's all in these packages, and there's a big list of them and what they are. we're not going into that, but you just need to know that this is CRAN and it has all of the R libraries in it. You can download them very simply, and when you do that, you can run all sorts of analytics. So, okay, so that's everything you need to know about logistic regression using the R programming language.